Throughout this semester, our team worked to implement an intelligent home system that uses multi-agent negotiation strategies to select the most beneficial deals for buying and selling electricity. To achieve this task, we overcame many hurdles and familiarized ourselves with many new learning areas, including implementing a neural network for a practical purpose, understanding how independent agents construct strategies, using the Jade architecture and ACL messaging system, working with large datasets, cleaning it and importing it into a Java project, designing a GUI and linking it to a project, working with external libraries, using Git, and collaboration on a large software project. We started by creating the appliance agents, which have a fairly simple messaging protocol except for the electric car agent that requires permission from the home before it commences charging. Next, we designed the retailer agents, which interact directly with the home to buy and sell energy. The home agent moderates communication between these two sets of agents, with the goal of reducing the cost of energy. In addition to these basic requirements, we also implemented a solar panel agent that provides free energy for the home, and a battery agent that stores excess power. This feature allows the home to implement a selling strategy to sell excess energy back to the retailers. Our group originally consisted of 3 members, Qian Zhu, Timothy Quill, and a third member that unfortunately left during the project. The remaining members equally divided the work to focus on different areas of the project. Qian focused on most of the agent implementation, as well as the logic of the program. This included home agent, selling process, limited buying process, contract buying process, small amount buying process, all application agent with their methods, interaction and negotiation with home, interaction with battery agent, most selling strategies, and using Python and TensorFlow to create a machine learning model to predict the solar plane energy generation based on history data. Tim worked on the other areas of the program that included designing and implementing the GUI, then linking it up to the program, sourcing, cleaning, and linking data for the appliances, solar panel, and weather, creating the main class, which executes all of the agents programmatically, reads in the CSV file and passes it to the required agents, creating the clock class that keeps track of the time and date, initial design and implementation of the other agents, making our group's video, and designing and implementing the scenarios. The solar panel communicates directly with the battery, sending it an application generation message that contains an energy amount for the battery. The battery can instigate 2 warning messages based on its current storage amount. The home can send a home energy require message to request energy from the battery. The home can instigate several messages to determine the current price and supply period from the retailers. If it is satisfied, it will send an energy confirm message, agreeing to buy an amount of energy which the retailer will send in its reply message. The home selling protocol is similar to the buying one. The home will inquire about the selling price from each of the retailers, and after it receives all of its offers, it will choose the highest price and send an energy selling confirm message that contains the amount of energy it is selling. The appliances communicate directly with the home by sending an application require energy message that contains the amount of energy they require. The home replies with the amount of energy. The electric car agent is slightly different, however, as it sends the home an application car charge message containing the amount of energy it requires. If the battery is sufficiently charged, then the home will send approval and the car will charge, otherwise it won't. We designed 4 retailer agents, each with their own unique pricing system, and all based on a real-world energy tariff. Firstly, there's the fixed price tariff. That is the standard residential retail electricity tariff for general domestic residential electricity supply. Energy customers pay the same price for each unit of energy used, whatever the time of day, plus a daily supply charge. Secondly, there's the bulk tariff, which offers a low rate, but you have to buy a certain amount of power at one time. Thirdly, there's the in-demand tariff that offers a very low rate, but if the customer goes beyond the agreed upon amount, they will be charged a very high penalty rate. Finally, there's the limited tariff that is very low, however it's only available for a certain amount of time per day. We felt that these tariffs allowed our home to be able to exercise some complex negotiating strategies and get the best available deal depending on their current and future circumstances. These negotiation strategies include future planning, as the home agent can anticipate its future needs and buy energy from the limited agent even when it currently has enough energy stored in its battery to take advantage of the low offer. Cautious buying, the home can buy a little more energy than it needs because it can store it in the battery for later. Use forecast data to predict hourly energy storage from appliances and solar power generation based on weather forecast. The retailer's negotiation strategies include the in-demand retailer's ability to alternate its price depending on how often it is chosen by the home. If it is not chosen for a certain amount of time, the in-demand agent will lower its prices. And if it is constantly chosen by the home agent, then it will raise its prices. We passed training data into our neural network. It output a text file containing reliable weights for each of our variables that we could use to predict future events. Our program contains thoroughly commented, well-structured code. We achieve most of our criteria, including some additions, including the battery and solar panel. Our agents possess sophisticated ability to communicate and plan. The program is generally able to outperform a home that only uses a fixed agent. However, it could still be improved as it has the tendency to buy more energy than it needs. The selling process is mostly functional, though there's some issues with the bulk retailer's selling protocol that needs to be corrected for the project to work properly. The management of our project was mostly good. We regularly spoke to our tutor for feedback and advice, and we organized ourselves well, especially when our team member left. We could have benefited from having more regular meetings though.